Hi, I have good news for you. I have finally made an exceptional release for CaffC. And the reason why it's so exceptional, it's because besides having now multi-compiler support, so we're supporting XLC, we're supporting Clang, we're supporting GCC, and not only we're supporting GCC, we're actually compiling with libasan as well. So we're actually validating, we're not doing anything weird with the memory. Besides all of that, we introduced project support. So we actually have now a CaffC YAML, which specifies various compiler settings. Right now we have I think only one or two settings, but the idea is to extend this and to have it configurable where your project would basically already specify all the stuff you would normally pass into the CaffC command line. Besides all of that, there's also now some collections which are introduced, right? We have some AI generated collections. Yes, they're AI generated. This is just to test the waters to see how fast can we go, how fast can we iterate, and can we even generate code with the AI? And the short answer is yes, and I was pleasantly surprised actually on what we got. We're still a far way to go. There are some problems in the interfaces, how they're getting called and what's happening. And this is not the problem of the AI. This is, some problem which yours truly, has to figure out. Besides of that, the reason why this is an exceptional release is because we have exceptions. So it's got to be exceptional if you have exceptions. So without further ado, let's jump right into the code and see what makes these exceptions, in my opinion, exceptional, right? I know it's a bad joke, but the feature is amazing. So let's jump into the code. As you know, there's a bunch of projects where I'm testing various scenarios where I'm coding some random stuff and trying to see, does this work? So for example, one of them, which is so far the most advanced integration test, is the list folder. Now, the list folder, it's named so, not as a trick, it's because it's actually a program that lists a folder using the POSIX API. So let's run it. What it will normally do, so list folder, and then we're going to run the compiled stuff. You can now point to a folder. It used to just list the current folder, but now because we have, string arguments and so on, I can actually specify. So let's say I want to list the current folder. There you go. I have, the same listing that I saw before. Now, what changed is, first of all, we have the option to configure what folder we're listing. Before, as I said, it was only listing the current folder. Now it can actually list the argument which we want. And because you see all of these now, right, the strings which we're passing, they're being converted to CaffC strings, right? So they're like normal garbage collected strings. I don't have to think about, okay, do I allocate, do I free, do I, none of these issues. What we do now is we're listing the folder, and this is the first big change. The array list is one of those collections I told you about. So this is basically a collection which is generated. It used to be in this project. It used to be just a class which would hold a list, an array internally of a bunch of file classes. Now this is actually a collection from the language. As I said, there are some issues with interfaces. So this is why I can't have here an interface being list of file and the array list allocated as, an array list. There are some issues still to be ironed out, but again, the general idea seems to be very solid. And then we're still calling the sorting, and afterwards we would just iterate with the for. And this for was actually AI generated, which I was very impressed. By the way, all the code which is AI generated, I personally review. Okay, so even if there will be some things like, maybe some slight mistakes, I would probably have written them myself. So, but for the most part, a lot of the code is actually really bad when the AI generates it. But if we prompt it good enough and, smart enough, we can get it to do what we want in a lot of the cases. So now we have basically iterating over collections. We can have stuff which implements iterable, and that's how we're listing out the files. And also, and this is a very nice thing, you notice this catch in here? Well, this is because this function can actually throw exceptions, right? We can throw exceptions, and the exceptions can propagate. Good. So how do we throw the exceptions? And we're mostly interested, like we know how to throw an exception in here. I can always say something like, throw new exception, and then we put a message in there. It isn't working, and then there is no parent to it, okay? So we have this, right? If I would run this, so let's go now to here, into the actual test, to the list folder. We're gonna compile this. And then if I run it, well, surprise, surprise, it isn't working, right? We threw the exception is caught. What we're interested in, how do we throw exceptions in native code, right? I'm in the middle of something and I gotta throw, an exception. So this is the code actually, which was doing the listing. I will refactor this in the future because I think there's a better way we can structure native code. It's great that we can just call it like this, but there's two problems, and I will explain immediately what are these problems. The first problem we see in here is that after we're actually throwing the exception, okay, so this function internally is just going to set a global variable, which is the exception, and between each instruction, between each function call, more specifically, not each instruction, we're just checking if the exception was set. So if the exception was set, we're just jumping then to where the exception handling happens. That's all the code. So this one would set the global variable. It would create the exception instance internally and whatnot, set the global instance variable. But then it has to jump at the end, right? Because we still have to do close dir. We've opened here, maybe there is something we might need to close dir. I mean, in this particular case, it cannot be because I just checked if it's not null. In this case, it has to be null. Shady stuff. But imagine it would be a resource, where we actually have to do stuff. We would have to jump there and do some sort of cleanup, right? But we already have try finally for this. Why are we doing this kind of nonsense in the first place, right? That would be the first problem. The other problem is this go to. What can happen is imagine you're inside of a native code. Now this native code, you don't want to think about the exception itself, right? Sure, the exception could happen, but the idea is what we would expect if you see this code is somehow magically, it just jumps out the end. So I'm planning to replace this with a macro, which would actually do basically a jump at the end, and the native blocks would have also a hidden label. Would have a hidden label at the end. You wouldn't see it. You're not declaring it. It's automatically declared for you. And then they would just have a jump at the end. This also has, though, a slight side effect. The side effect is that if there is no throw, it's a bit tricky to find out if I actually need the label or not, because you will get compiler warnings, because C will see there's a label which is not referenced, no one jumps to it, why the heck there's a label? Again, these are some technicalities, but this is how we can do it, right? We can actually go ahead and throw exceptions from there, and the exceptions will land into our program. And now our program is actually much, much nicer. So if I'm doing just a target main, I have to remove the exception I'm throwing in the middle of things, right? I removed it already. Oops, let's make sure I did. Let's recompile. And then if I want to list root, for example, you see I get permission denied, and this permission denied actually comes as error number, gets converted to string, and gets printed as a CaffC string. In my opinion, beautiful stuff. And this is, again, we're just building on the work we built so far. This is nothing new in the sense of we already had creating strings from pointers. This already existed in a previous release. We just, we're starting using now more and more stuff because we want to get to the locale support, right? That's the whole idea in here. We're just trying to get locale support. We want to have the UTF strings internally escaped as UTF-8, and we want to be able to get data in. Let's say we're running on, again, some crazy mainframe, EBCDIC. We will take the EBCDIC, convert it as UTF-8 internally, do all the operations internally as UTF-8. And this also has benefits like, AZ comparison and stuff like that, because in those code pages, they're not linear. Cool stuff. So we want to have it like this. And then when we spit out the data back, we can also choose, maybe we want a different code page, right? So this is the idea. And for this, we want dictionaries to do like searches in the code pages, in the actual mappings. We want to have global variables next. This is the other feature we're going to implement next, and so on and so forth. But we will see as we go what is actually needed. And of course, we have to iron out eventual bugs we find out. Yes, and the last thing I wanted to mention, besides the exceptions, where these are just exceptions at the end of the day, right? You know them, I know them. Yeah, it is what it is. It's this. As I mentioned, we have now support for multiple compilers, and there's a sweet regression which can actually run the matrix of the tests. As you can see, it actually takes a lot of time for XLC because I'm running with emulation, but it is what it is. However, the cool part is in gcc-asan, we're also running with libasan. Asan is a library which can check memory violations. It can see if we forgot to free memory, if we write, bytes in the wrong places, which are not on our stack, and so on and so forth. And this we do now for every single release. But you notice there is a test failing. That is intentional. So we see that gcc-asan itself actually functions, right? We don't want to have a case where everything is passing because asan is not enabled. Like, what kind of test is that, right? And I can show you the code. I intentionally made it fail because anyways, the native code, and by this stage, we're already very, very far. I'm not really testing the native basic block. So this was initially when the compiler was in the very beginning, sorry. And we had kind of nothing. It was like the first thing I'm going to implement is the native block because it's the easiest. I just take the code, throw it back to the compiler. So in here, we have now an intentional out of bounds write. This is the array in the middle. We're basically writing to, I think, the next array in here. We're writing a byte, and we do an malloc, again, intentionally, and that's it. And we would do a printf, but really, asan is going to die here immediately. So this is really nice, again, because we can just validate. I also saw Clang also validates this. I was very impressed because it did it just by some sort of default. Again, very impressive stuff. But yeah, that's basically it. We're validating the memory now. We're having exceptions. We're trying to get further. I should switch back to my main camera. Yeah, so now this is basically it. We have exceptions, we have multi-compiler support, we have the project support. I haven't shown it to you, but again, it's just a YAML file. We can configure minor stuff. So far, it's nothing really useful. It's just for me, for my testing so far. When it's going to be something more fleshed out, I will show it. And we have like the initial collection support, right? All of these, you see, it's starting to get shape into something more tangible, something more real, where we can actually do more stuff with it. And hopefully, again, in the next release, we'll finally get localis. Probably not, to be honest. Probably we'll just get global variables, but it is what it is. The reason why all of these are a bit tricky is because we always have to configure now also the garbage collector to know about these global variables. There is a few things we have to be careful when we do this. And again, I want to iron out also some bugs. There is some stuff, for example, where there's no checks now. For example, if you can assign stuff to other stuff, it just, sure, it's going to work. Let's hope, And I want to also start introducing these checks as well, because they make sense. The idea is to have a language which is very easy to learn, looks a lot like the other languages you would know, C, C++, C#, Java, with garbage collector. There shouldn't be anything very trippy about it. It should be very simple. You would know I'm doing new, it's memory, like anything, and then it's going to get freed and it's just going to work. And if I do something like super weird, where I assign variables of the wrong type, I get errors. And very basic stuff. But then I always have this option. I want to just jump into the system though. I want to do something in the system. I just open a native block and it is what it is, And as I said, I have a pattern, I think, for how to deal with native blocks better than what we saw in the listing, and we'll see the next time. Good. Thank you for staying with me for so long. Thank you for your time, and let's see us in the next release. Have a good day.